Today we are going to do Neet 2018 question paper. So we will begin with physics. So our first question is, the volume V of a monoatomic gas varies with its temperature T as shown in the graph. The ratio of work done by the gas to the heat absorbed by it when it goes a change from state A to state B. So let's see its solution. So here is our solution. In this given figure, the graph is between volume and temperature. So here V and T are constant, so the process is isobaric. So from the first law of thermodynamics, we know that delta Q is equal to delta W plus delta U. Here delta Q is total heat absorbed or given, is equal to work done plus internal energy. So here if V is constant, as we have the formula of W is P delta V. If V is constant, then W is equal to 0. So our delta Q will be equal to delta U. And we know that delta U is NCP dt. So here for monoatomic gas, F is equal to 3. We know that. So CV is equal to F by 2 R. So we know that Cp minus Cv is equal to R. It's a Mayer relationship. So Cp is equal to Cv plus R, and therefore Cp will now become F by 2 R plus R. So here by putting the value of F, that is 3 for a monoatomic gas, given here, is Cp is equal to R plus 3 by 2 R, that is 5 by 2 R. So we have got the value of Cp. Now in the question it is asking the ratio between work done and heat absorbed. So work done, we know that the very nice formula, it is for ideal gas, PV is equal to nRT, and we know that PV is work done. So nRT will be delta W is equal to nR delta T. And delta Q here, as the mentioned above, NCP dt. So nRT and by n 5 by 2 RT, we had just got the formula F by 2 R. So our answer will be 2 by 5. So here correct option is 2 by 5. Now question number 2, the fundamental frequency in an open organ pipe is equal to the third harmonic of a closed organ pipe. If the length of the closed organ pipe is 20 centimeter, the length of open organ pipe, the length of open organ pipe is equal to 3 into length of closed organ pipe. Here it's it is for first harmonic, and this is for third harmonic. So this statement is according to question, this line. So we know that for open organ pipe V by 2L we have, and for closed organ pipe we have V by 4L and 3 as according to question. So L dash will be 2 by 3 into 20, as 20 is the length which is given in the question. So 40 by 3 is equal to 13.3 centimeter. And it's just a thing to remember that for open organ pipe, it is double, the frequency of the open organ pipe is equal to double of frequency of closed organ pipe. So here our correct option is 13.3 centimeter. Now question number 3. At what temperature will the RMS speed of oxygen molecules become just sufficient for escaping from the Earth's atmosphere? Mass of oxygen molecule is here given, and Boltzmann constant Kb is also given here. So in this question it is clearly said that escape velocity, here the sufficient for escaping for Earth atmosphere, that velocity in which when we throw a particle upwards, it just escape the Earth's gravity, it does not fall down. So that is known as escape velocity. So here according to the question it is given that Vrms is equal to Ve for escape velocity. So we know that Vrms is equal to 3 kBt and root 3 kBt by mass. So here the element is oxygen, so we will take mass of oxygen, and escape velocity is root 2 gr. So it is, escape velocity is fixed everywhere, that is 11.2 into 10 to the power 3 meter per second. And here the value of kb is given in the question, 1.38 into 10 to the power minus 3, and T, here we just have to know the temperature. So here T we have to find out, and the mass of oxygen is given in the question. So T, after solving this come out to be 8.3626 into 10 to the power 4 K Kelvin. So here is our answer, which is matching to the answer. Now question number 4. The efficiency of an ideal heat engine working between the freezing point and boiling point of water is. So here our correct solution is, efficiency of ideal heat engine is N. Efficiency is eta, it denoted as eta, that is 1 by T2 by T1. So N is equal to, so T2 is the temperature of source and T1 is the temperature of sink. So we know that freezing point of water is 273 as we take it in Kelvin, and boiling point is 373. So 1 minus 273 by 373, as here our source is freezing point of water and our sink here is considered as boiling point of water. So here we put the values and we get 0.268, or we can tell it is as it is efficiency, so we will take it in percentage, 26.8%. So here it is option 26.8%. A carbon resistor of 47 plus minus 4.7 kilo ohm is to be marked with rings of different colors for identification. The color code sequence is, so here our correct option is B, yellow, violet, orange and silver. We can just remember this color coding by a very famous trick, which is B.B. Roy of Great Britain has a very good wife. So by putting in that, we can just know this color coding. Now question number 6. A set of n equal resistors of value RH are connected in series to a battery of EMF E and internal resistance R. The current drawn is I. Now the n resistors are connected in the parallel to the same battery. Then the current drawn from the battery becomes 10I. The value of n is. So it is given in series. We know that the formula of n cells connected in series is I is equal to E by NR plus R, where R is external and R is internal resistance. So according to question, it is given here that internal resistance is equal to external resistance, as it have all the resistance same resistance. So here R becomes R is equal to E by R n plus 1. So for parallel, this NR becomes R by N. This is the only difference in the formula. E and R are same, but here NR becomes R by N. So here also we will use that this two then becomes same as given the question. So according to question, it is that it was the previous current when it was connected with the connected in the series form, and this is when it was connected in the parallel form. So I dash value here is E by R by N plus R. No, it is of parallel form, and this is of sorry, so according to the question, it is I dash is equal to 10I. It is given in the question, and we know that the value of I dash here is E by R by N plus R. So here we have just put it, and 10I, so NE by N plus 1 R. So now it's 10I, equation 2. This was our equation 1 and this was our equation 2 for this was for parallel and this was for series. Now from equation 1 and 2 we will just combine it. This is for our parallel and this is for our series. So after getting, we get the value of n, this is 10. So your correct option of n is 10. Now question number 7. A battery consists of a variable number n of identical cells having internal resistance R each, which is connected in series. The terminals of the battery are short circuited and the current is then measured. Which of the graphs shows the correct relationship between I and n? So I hope that these 4 graphs are visible to you. See. Now equivalent EMF will be NE and equivalent internal resistance will be NR. This is for series. So then V is equal to IR, we know the very popular equation. So I is equal to E by R. Here E voltage or EMF is same. So NE by NR, from previous we had got that. So I is equal to E by R, that is constant. So here our relation will be this, where E and R are constant. So I is also constant and we get this value. Now question number 8. Unpolarized light is incident from air to a plane surface of a material of refractive index mu. At a particular angle of incidence, it is found that the reflected and refracted rays are perpendicular to each other. Which of the following option is correct for this situation? So here is our correct option B. Reflected light is polarized with its electric vector perpendicular to the plane of incidence. Now question number 9. In Young's double slit experiment, the separation D between the slits is 2 mm. The wavelength lambda of the light used is 5896 angstrom and distance D between the screen and the slit is 100 cm. It is found that the angular width of the fringes is 0.20 degree. To increase the angular width to 0.21 degree with same lambda and D, the separation between slits need to be changed. So here as it is seen that and D will be same, so it would be constant, and we just have to know the value of small d, that is distance between the two slits. So here we know the formula, angular width is equal to theta is equal to lambda by D, distance between the slits, and here D and lambda are same, so so it's according to question. Actually it's lambda D by T. So theta is directly proportional to 1 by D. So theta 1 by theta 2 is equal to D2 by D1. So here we will put the value of theta 1 and here the theta 2, which was first 0.20, then it had become 0.21, and D2 by 2. First it was the distance between slit was 2 millimeter. So now our answer is 1.9 millimeter. So here is also our answer, 1.9 millimeter. 10. An astronomical refracting telescope will have large angular magnification and high angular resolution when it has an objective lens of. So here our correct option is C, small focal length and large diameter. As we know, this resolution power of telescope is A by 1.22 lambda, 1.22 lambda. So R, that is the resolution power, is directly proportional to A, that is diameter. So large diameter is important and small focal length is also important. Now question number 11. The ratio of kinetic energy to the total energy of an electron in a Bohr orbit of hydrogen atom is. So its kinetic energy is equal to RHc by n square. It is Bohr orbit of hydrogen atom, and total energy is minus RHc by n square, that is equal. From equation 1 and 2 we get Ke by Te is equal to RHc by n square and minus RHc by n square, that is 1:-1 ratio. So here it is seen 1:-1 ratio. Now an electron of mass m with a velocity v is equal to v naught I cap. Just notice this v naught I cap, that is on the x direction, positive x direction, which is greater than 0, enters electric field of minus E naught I cap. So just note this, it is also minus, so it is minus x axis, this is, and it is also constant and more than 0, and t is equal to 0. If lambda is de Broglie wavelength initially, then its de Broglie wavelength at time t is. So according to question we get this type of diagram where m is this positive side and this is negative side. So we know F is equal to QE, and for electron it is E naught and MA. So A is equal to E naught by M, and A is equal to minus E naught I cap by m as it is given in the question. So it comes out to be E naught by m I cap I. We know that V is equal to U plus AT. So V is equal to V naught, as initial it is V naught. V naught plus E naught by m into T. So it is equation number 2. You know, de Broglie wavelength is lambda by is equal to H by m mv naught, that is for initial, and H by mv is for after time t. So we will just substitute the value. Lambda is equal to H by mv. So we will substitute the value of V. This V naught is equal to E naught by mt here, and the value of H. The value of H here comes out to be lambda mv naught. From this equation it becomes this. So we will put this value also, lambda mv naught by mv naught 1 plus E naught by mv naught t. So lambda is equal to lambda naught 1 plus E naught by mv naught t. So here is our option, third option. Now question number 13. For a radioactive material, half-life is 10 minutes if initially there are 600 number of nuclei. The time taken in minutes for the disintegration of 450 nuclei is, we know that our formula is n is equal to n naught 1 by 2n. So here it's nothing. So here n naught initial will be 600, and we know that we calculate in the terms of which is left, not which is disintegrated. So 450 is disintegrated, it is over. Now left is 150. So here n by n naught is equal to 1 by 2n. So we will put the value 150 by 600 is equal to 1 by 2 to power 2. As we know that if here it comes out to be 1 by 4, so that is 1 by 2 power 2. So we had just put the n's value here, and then this both will be same. This will also can be written as 1 by 2 to power 2. Now n by n naught is equal to 1 by 2 power 2. So we will just put the value t is equal to 2 into t half, that is 2 into 10, that is 20 minutes. So here our correct option is 20 minutes. Now when the light of frequency 2 mu naught, where mu naught is threshold frequency, is incident on a metal plate, the maximum velocity of electron emitted is mu 1. When the frequency of the incident radiation is increased to 5 mu naught, the maximum velocity of the electrons emitted from the same plate is V2. The ratio of V1 to V2 is. So here is our correct explanation. We know that Einstein photoelectric equation is K max is equal to half mv square max, that is h nu minus h nu naught also, that is h nu, and h nu naught is known as work function. According to the question, first mu changes into 2 mu naught. I mean the value of mu is here 2 mu naught. So half m1 v1 square is equal to h, as it is for incident, it is for which is incident to the metal, that frequency it is. So h 2 mu naught minus h nu naught, so that comes out to be h nu naught. According to the question, now it becomes 5 nu naught, so we will just put the values and we get 4 h nu naught. From equation 1 and 2, we will just half mv1 square by half mv2 square h nu by 4 h nu naught. So v1 by v2 square is equal to 1 by 4, is v1 by v2 is equal to 1 by 2, as we will just bring note here. So v1 is to v2 will become 1 is to 2. So this is your option, correct option, 1 is to 2. Now in the circuit shown in the figure, the input voltage Vi is 20 volt, VB is 0, VC is equal to 0. The values of IB, IC and beta is given by. So this is our question where current grows from here, that is RB, that comes out to be 500 into 10 to the power 3 ohm. Then it goes to this emitter side, and collector side also one current comes. So it is 20 volt given. So RC it is given 4 kilo ohm, that is 4 into 10 to the power 3 kilo. According to in question it is given VBE is equal to 0 volt, Vc is also 0 volt, Vi is 20 volt. So Kirchhoff law of base and ammeter, we know Vi, then by this seeing this figure also we can get the idea. Vi, that is IB RB plus VBE, that is for base. Vi is equal to for base and for base ammeter. So it is 20 is equal to IB into RB value is given here. See, this value we will put here, and VB is 0 from the question. So IB is equal to 40 milliampere. Now here VCC is equal to ICRC plus VCE. So 20 is equal to, here it is given in the question. See here, VCC is equal to 20 volt. So ICRC plus VCE, so 20 is equal to IC into 4 into 10 to the power 3 plus 0. So 5 is equal to, so IC is equal to 5 milliampere. Sorry. So current gain, we know that IC by IB. So we will just put the values and we get 0.125 into 10 to the power 3. So here our correct option is this, where it is given 125. This. Now question number 16. In PN junction diode, change in temperature due to heating is, so it is D, affects the overall VI characteristics of PN junction. Due to increase in temperature, its thermal collisions will also increase, and then the electron and holes increase. So it affects all the VI characteristic of a PN junction. Now question number 17. The combination of the following gates, the output Y can be written in the terms of A and B as. So here you can see A and B. It is given. So as it here is not this 0 type structure, it tells that it reverts. So B, line is upper line is added, a mod is added, so dash is added. So here that B dash continues to here, and the A is here is nothing. So A. So in this gate, C, its value is A into B dash, as it is here. So you can see. So its C value will continue here, and the Y is equal to C. Now in this case, from B you can see this A, this which is A here converts to here A dash. So A dash is input here, and B is here another no dash, only B is here another input. So it now comes to be D. So C plus D. So AB here we can see A. It's not AB, is AB dash, and here A dash B. So we can see here AB dash plus A dash B. Here is the answer. Now question number 18. An EM wave is propagating in a medium with a velocity V is equal to Vi. I hope you can see this. It is I cap, so it is on the J direction. Now the instantaneous oscillating electric field of the EM wave is along Y direction, that is on the J side. Electric field is toward J side and velocity is toward this I side, that is X. Then the direction of oscillating magnetic field of EM wave will be along. Now we just have to see, in this question the direction of velocity and electric field is given. We have just to find out the direction of magnetic field. So when we had seen the graph or this type of graph, so we in that chapter only we had done that velocity is in this direction, electric field is in upward direction, and magnetic field was in like this type. We had studied this. B direction was here, E direction was on the upper side, like this way. We had just done this in chapter electromagnetic waves. So it is clearly given that B direction is here, that is plus Z side. It is C here, plus Z direction is given as option. The refractive index of the material of a prism is √2 and the angle of the prism is 30 degree. One of the two refracting surface of the prism is made a mirror inverts by silver coating. A beam of monochromatic light entering the prism from the other surface will retrace its path. It means that when it goes there, it just gets reflected. And after reflection from the shivered surface, if its angle of incidence on the prism is, we just have to find the angle of incidence, that is I. So here is the figure. You can see this is the light. You can see here clearly light is entering. Here is R1, the refractive index √2, and it is just when it goes here, it just comes back as this surface is shivered type. So here, so R2 will become automatically 0. So according to your question, it is given the question A is 30 degree here, angle of prism A, and mu is √2. So according to this figure, we can see that angle ARO, this is equal to angle ORC 90 degree. Yes, as consider this as a straight line and this as a line passing from the mid side. We know that we have just studied in maths that when a straight in a straight line, how many lines which will add here will be, its total sum will be 180 degree. So here in this question only like this, so 90 we can assume it 90 degree 90 degree, so it is just here. In triangle AOR, see A, O and R, it is given in the question 30 degree. OAR 30 degree is given in the question. ARO we had find out is 90 degree, and AOR we will find out. So AOR will become 60 degree, will come out to be 60 degree. We know that angle AOR, see here, AOR plus R1 is 90 degrees. See, this is R1. AOR plus R1 here is 90 degree. Yes, as we can see. So angle R1 is equal to 30 degree. As this is 60 degree, so it comes out to be 30 degree. Snell's law, mu is equal to sin I by sin R1. So here mu value given √2 sin I by sin 30 degree. It is given. We had find out here R1. So the value of sin I after substituting all the values come out to be 45 degree. Here you see 45 degree. An object is placed at a distance of 40 cm from a concave mirror of focal length 15 cm. If the object is displaced through a distance of 20 cm towards the mirror, the displacement of the object will be. So in this question it is telling that an object is placed on the distance of 40 cm. Then that object is just pushed toward the mirror, and that object now is on the 20 cm towards the mirror. Now let's see the displacement of the object. What is the displacement of image? So we just have to find out V, that is the distance of image from the lens. So in this question it is given mirror. So here case 1, let's see case 1 when the object was on 40 centimeter. We know that we take, when objects are this side we will take it negative, this side we will take as positive. So in the concave mirror everything is in this side, so minus 15 centimeter. So mirror formula we know 1 by F is equal to 1 by V1 plus 1 by V2, as we are studying here two cases, so I am just numbering it as V1 and V2. So minus 1 by 15 as it is in negative is equal to 1 by V1, as we have to know this image, distance of image. So after substituting the values we get V1 is equal to minus 24 centimeter. So that this image distance was our first image distance when the object was on 40 centimeter. The image was formed on 20 centimeter. Now case number 2, when it is shifted towards the mirror 20 centimeter. So we will just put the values F minus 15, V2 we have to find out, U is equal to 1 by 20. So V2 comes out to be minus 60. So displacement of the image will be V2 minus V1. This is minus 60 minus 24. That comes out to be minus 60 plus 24. Then the correct answer is minus 36. So here our answer is here. Let's see. This is 30 centimeter away from the mirror and 30 centimeter towards the mirror. So our correct option is here B. 36 centimeter away from the mirror, as we know that the image will form. It will form away from the mirror. The magnetic potential energy stored in a certain inductor is 25 mJ when the current in the inductor is 60 mA. The inductor of the inductance is, in this question, the energy stored in the inductor we know is equal to half Li square. So the value of here we will give 25 into 10 to the power minus 3. It is given in the question. Half into we had to find the value of L, and I is also given 60 into 10 to the power minus 3 ampere. So we'll just do it square. That comes out to be L is equal to 13.89 Henry. So correct option is 13.89 Henry. Now question number 22. An electron falls from the rest through a vertical distance h in a uniform and vertically upward direction electric field E. The direction of electric field is now reversed. Keeping its magnitude the same, a proton is allowed to fall from rest in it through the same vertical distance h. The time of fall of electron in comparison to the time of fall of proton is, so if we know that F is equal to Q and this is also equal to Ma, so QA is equal to QE by M. It is given that U is equal to 0 as particle and particle is at distance as, so we will use this formula as is equal to UT plus half AT square. So U is equal to 0, so H equal to 0 into 2 plus half AT square is equal to half into QE by MT square. T is equal to root 2HM by QE. So it is given that QP is equal to QE is equal to E. So here we comes in that in a conclusion that T is we will just put this value, this 2H by QE as a proportional K. So here it is K root M. So this T depends upon M, that is mass. Time depends upon mass. So whose mass is greater, that will take more time, and whose mass is less will take less time. So here we know that mass of proton is much greater than mass of electron. So here it is the time of fall of electron. That electron will fall in less time as its mass is less than proton. So it comes out to be smaller. Now question number 23. The electrostatic force between the metal plates of an isolated parallel plate capacitor C having a charge Q and the area A is, so here as you know that work done here is equal to half Q square by C. So it is also force into displacement, force between two plates of capacitor and distance between them. So here Q square by 2C is equal to F into D. So F here becomes Q square by 2CD, and we know that the value of C is equal to E naught A by D. So we will just put this value E naught A by D, and this comes to be F is equal to Q square by 2 E naught. So here the option is C, independent of the distance between the plates. So we know that from the force here when we have get the value of force is Q square by 2 E naught A. Our force depend upon Q A, but it does not. Yes, it depends upon Q. It depends upon A, but it does not depend upon the distance between them. Question number 24. A tuning fork is used to produce resonance in a glass tube. The length of the air column in this tube can be adjusted by a variable piston. At the room temperature of 27 degrees Celsius, two successive resonances are produced at 20 centimeter and 73 centimeter of column length. If the frequency of the tuning fork is 320 Hz, the velocity of sound in air at 27 degrees Celsius is. So here for first resonance it is our formula L1 is equal to lambda by 4. Now for second it comes out to be L2 is equal to 3 lambda by 4. 1, 3, 5, 7, it comes in odd number resonance. So here L2 minus L1 is equal to 3 lambda by 4 minus lambda by 4. That comes out to be lambda is equal to 2 L2 minus L1. we have to find the velocity of sound wave. We know that velocity is equal to wavelength into frequency. You can see here. So here V is equal to mu by 2 L2 minus L1. So it comes out to be 2 here. Value of mu is given 320 Hertz. And L2 is 0.73 minus 0.20. So V comes out to be 339.2 meter per second. That is 339 meter per second. So as it is, see, 339 meter per second. Now, our question number 25. A pendulum is hung from the roof of a sufficiently high building and is moving freely to and fro like a simple harmonic oscillator. The acceleration of the bob of the pendulum is 20 meter per second square at the distance of 5 meter from the mean position. The time period of oscillation is, so now that acceleration in simple harmonic motion is minus omega square x. So we will not use minus. We had just given a mod here. And also time doesn't come in negative. It comes in only positive. So A is equal to omega square x. So acceleration value is given here. That is 20 meter per second square. And omega square into 5. So omega square comes out to be 4. See. Now we know that value of t is 2 pi by omega. So we will just substitute its value, 2 pi by 2, that is pi second. So here our correct option is pi second. In this video we had done 25 questions of Neet 2018. So I hope in the next video we will just complete it. Only 25 questions of physics, 20 questions of physics are left. I will try to do it in the next video, and I will upload that video tomorrow. So thank you.